Okay, thank you very much. I'm going to keep this fairly short, hopefully. What I'm going to talk about is some of the CAD design issues. As we've seen this morning and yesterday, just about all the boats are now designed using computer-aided design. And this is all about, okay, how do you get a better representation of the person that's actually going to use it into that design process so that the ergonomics and the human factors that Bob talked about can be addressed as early as possible. How do we fix this? This obviously is a racing boat scenario, but we tend to use quite a few racing boat pictures because they're the ones who actually have a camera on the boat at the time. This does happen on military boats, but it gives you an indication of what happens. When this boat pitches and rolls, you might say, yes, I've got all the handholds in the world, but when it rolls fast enough, you are just going out of the boat. So how do we address this as best we can? A lot of you will have seen this before. This was a human factors design guide that was produced, sponsored by the MOD, with a lot of assistance from the US Navy and other organizations. It's available as a free download from the internet, about 120 pages. There's an awful lot of color in it, so find somebody else with the color printer before you press print. But it's been well received and well used around the world. This was a bit of background that supports some of this work. I put up this reference yesterday from the MCA. And so this is the part of it that talks about posture and getting the boat actually designed around the person. There should be features that allow the person to maintain their postural stability. Seating, foot straps, handholds all be in the right place. Maintaining neutral spinal alignment. Facing the direction of travel. Reducing the incidence of twisted spines and therefore reducing the risk of injury. So what I'm going to talk about supports some of this. Like I say, you can just search for this online and download it for free. Mock-ups are used, not as much as they could be, but even then when people build a good mock-up, so this obviously took an awful lot of time and effort to produce, but if you actually sit in this seat, can you actually operate all of these effectively? If you're sat in a mock-up and you're already leaning forward to operate this, it would suggest that some modifications are probably worth using. So just because you build it doesn't mean to say the boat couldn't be better, and how do you actually do some of that analysis. In the design guide, which I mentioned, we talk about 3 classes of mock-ups. This comes from a lot of the aviation world where they just could describe. Class 1 is cardboard boxes and general arrangement. Class 2 is more this kind of wooden mock-up, and a class 3 is almost the real thing and just looking at how do we actually integrate the systems into it. But not many people do this. This does take a lot of work. Is there a better way of actually achieving that? The CAD world is a wonderful thing these days. These pictures can now be virtually photorealistic, which gives a lot of idea of what something's going to look like at the end of the day. Yeah, so you have this great potential for enhancing the design process, but you can make it look really good. It can be very convincing, but at the end of the day, does it still work? And it's this point here of how do we visualize the human inside the craft? A lot of it is actually putting that human into the craft at an early point means that you can now leave space for them to work rather than thinking, oh yeah, there's enough space there and I can put some more equipment in. Actually, this is trying to actually say, no, leave more space in there rather than cramming it full. There are some examples of what we're going to call digital human models that are out there. Poser is one that some of you may have used. Jack is more of an ergonomic tool that some of the scientific world use. We've got some examples here of how it's used. Ramsys is another one that's used in the automotive industry. And so you can see where you've got this person and the software is clever enough where it gives you sight lines. You can actually hold the steering wheel. They can hold the gear levers. You can put people of very small, 5th percentile, to very tall, 95th percentile. And so you can tell it to press the pedals and then it will give itself the optimum position and you then move the seat into position underneath them. As I said, that's derived from the automotive industry. The problem for the boat world to get into this kind of technology is this will cost you 40,000 euros per seat per year to use that. which probably isn't realistic for just about everybody. We were able to use this to do some demonstrations. So somebody had designed a super yacht bridge command and control station. Looks really nice, but once you actually put the digital human into it, you can see that this isn't really going to be an effective solution. So having this capability means that we can do this before anything is actually really cut. An example of where this actually still happens in reality, this is a prototype boat, but this still does happen. One of the things that you can see on that, the Ramses work and the other one from Jack, is that generally they're dressed in jeans and t-shirt. What we actually need to get to is people are actually dressed in a lot of clothing and equipment, which then restricts their range of motion and makes them bigger. They need more space to actually move around the craft. So to say, it's about size and space envelopes. The ability to get that real clothing or the real sizes actually into the CAD world, as it says there, thermal protection, waterproof, life jackets, and then you add on the operational equipment as well. And what this does, it allows, here's an example of some CAD design and where you take a number of components, and within this you've got red lines where various integration is going on of putting all the components together. By making the human a component in your CAD design process means that you have a better visualization, identification of how to actually do that effectively. So the size and space envelopes, why do we need them? Getting in and out, moving around the craft. The seats that you've got in there, how do you get in and out of those effectively? Can I actually reach all the controls, the handholds? That can be just for the normal operation. Then you get into, okay, what about escape and evacuation? Something is damaged, the boat is upside down, can I actually still get out? And by being able to do that in CAD means that it's going to be a more successful solution. So how do we know once we get all dressed up, how does that actually compromise the design? So here's an example of motion capture. Some of you may have seen this from the animation world, where you'll see people dressed up with balls all over them here. Here's an example where you've got around 16 infrared cameras which measure people's actual movement. And so we did a couple of these wearing next to nothing and then wearing all the equipment to actually see what are those ranges of motion and how do they differ. So what I'm going to do, I'm going to play a couple of videos that look like this, but you've got a skeleton, and the lines that you'll see are the different ranges of motion. The light ones are without any clothing, and the yellow ones are with clothing. Okay, so what does this actually mean? There's a few points I want to try and pull out here. For example, if you're putting stuff up high that you can actually reach from a seated or a standing position, when you're wearing just t-shirt, you can reach to this kind of angle. Once you're actually wearing all the equipment, you can only reach to here. When you're wearing all the equipment, or when you're not wearing the equipment, you would sit on the seat, and this is your back against the back of the seat here. When you actually put all that equipment on, you're then pushed forward by around 10, 12, 15 centimeters. But interestingly, then when you look at the actual how far you can reach, it's around the same. So this is then restricted in how far you can extend your arms. But even though you put that on, you don't necessarily have to move the seat forward, because the reach envelope is approximately the same. On this example, you can see here, this is with the body armor on and all the other equipment. You can only reach so far in. When you haven't got that on, you can obviously reach further in. So if you're trying to position all the controls, this is the kind of thing you can consider with how far actually inside you can actually reach. But the next thing is, okay, how do you now take this and put this into the CAD environment? So here are some examples of a straddle seat being used with a console. And what we've done here is we've taken actual figures with equipment on, so people get an idea of, yes, that's actually how I look. You know, I don't go actually to work dressed in the jeans and a t-shirt. And this shows you that you can get these kind of figures in. We've taken the same ones and put them in different seating configurations, and this will give you an idea. Yes, here's a driver. This is somebody doing command and control navigation. And so you can say, okay, if I have two different boats, how do I ensure that I've got a degree of interoperability? They will work for my same occupants. And then what we did was to try and say, okay, well, we know what those range of motions now are. How does that actually work to make sure that you can actually reach everything? So we then drew in these arcs, and so it's more kind of obvious from above. So this is the range that they can actually reach to. So things that you need to do all the time need to be put inside of this. Things that you may use less often may be put outside of it, but it gives you an indication of how close things need to be to the people. So in conclusion, we were able to use some of the motion capture technology to actually look at, yes, we can see there is a difference, and we can actually measure that. The digital human models, you can get into the CAD environment and be very almost marine specific as to how much space do we need to leave for people. And so this tool does mean that you can get a better indication of what is that real person like whilst the designs are still on the drawing board, and actually design from those people with the command and control and the seating, and design out from that rather than designing the boat and then hoping that that person with all that equipment on will still fit and get in and out of the craft effectively. The work was supported by one of our government agencies and the MOD, so I'd like to thank for that. And just to ask if there's any questions, we're short of time. I'm sure we can talk afterwards.